These are the video notes for lesson 4.5 through 4.9. Okay, in this lesson, we're going to solve inequalities. Inequalities are symbols that are less than, greater than, less than or equal to, greater than or equal to. And the way we solve the equations is we solve them as if it has an equal sign, except for one very special rule. And that rule is that you must switch the inequality if you multiply or divide by a negative. So for a very quick example, if I had negative 5x is less than 25, in order to solve this, I would divide both sides by negative 5. Now normally we would just write x equals negative 5, but because it's an inequality and because we divided by a negative, I'm going to switch the inequality to a greater than symbol. So that is essentially this lesson. Now the other part is when I saw this, I made sure that the variable was always positive. So this rule really applies for those that don't follow my suggestion. So let's take a look at the first example. If I subtract 5x on both sides and then I subtract 3, I will get negative 10 is less than 3x. So because I bring over the smaller term, I avoid this negative with the variable, so therefore I don't really need that rule. And when I divide both sides by 3, I'll get negative 10/3 is less than x. Just for a quick reference, let's do it the other way so that you can see you'll get the same answer, and it's going to be more work. So I don't like subtracting 8x on both sides, but some of you might. And you'll get negative 3x is less than 10. Divide both sides by negative 3, and because we're dividing by a negative, we're going to switch the inequality. And this is the same answer as this. It's just the reverse. So both are acceptable, but again, you know I prefer to do it this way. So let's take a look at the next example. I'm going to subtract 3x, and I'm going to add 7 to both sides. And then this will be 2 is less than 2x. Divide both sides by 2. Sorry, my pen's kind of acting up. And this will be 1 is less than x. If you did it the other way, your answer would be x is greater than 1. Both mean the same thing. So whichever one, it depends on how you solve the equation. But if you do it the other way, you're going to have to use this rule that I discussed in the beginning. Okay, try these examples on your own. I'm going to go over this. I'm going to add 4x to both sides first. I'm going to subtract 2. So this will be 1 is greater than 3x. Oh, sorry, no, it's not 3x. 1 is greater than 11x. Divide both sides by 11. I'll get 1 over 11 is greater than x. Next one, negative 10x plus 14. I'm just distributing. So I'm going to bring over the smaller term. I'm going to add 12x to both sides, subtract 14. And then I'll have 2x is less than or equal to negative 13. Divide both sides by 2. And x is less than or equal to negative 13 over 2. Okay, so this lesson is going to combine our LCM trick from before and the inequality equation. So I'm going to multiply by the LCM. If you have trouble with this, make sure you go back to when I taught that. And so this is going to be 9x minus 5 parentheses 2 minus x is less than x minus 1. Going to distribute. Combine like terms. Subtract x on both sides, add 10. Running out of room here, I'm going to go 13x is less than 9. Divide both sides by 13. X is less than 9 over 13. Again, I said this before, but at the beginning of the previous lesson, when you multiply or divide by negative, you switch to inequality. But because of my, I guess, unique way of solving for equations, I almost always avoid a negative by bringing over the smaller variable. But in case you don't, you will have to use that rule. Okay, so this next example, the LCM is 6. So this would be 2x minus 3, 3x plus 1, less than or equal to 2x minus 1 plus 6. I'm going to distribute and then combine like terms on the right side. Combine like terms on the left side now. I'm going to add 7x and then subtract 5. I'm running out of room, so this will be, let me do it in a different color. I don't want you to think it's the one above. There you go. So now I'm going to get negative 8 is less than, oops, sorry, pen's not working. Negative 8 is less than 9x. Divide both sides by 9. And I'll get negative 8 ninths is less than x. Okay, try these examples on your own. Okay, I'm going to multiply by 6. Going to distribute. Combine like terms. Divide by 3. I get 1/3 is less than x. Okay, this next one, I know it looks a little intimidating, but I'm going to multiply by 30. So that'd be negative 10. Sorry, just thinking if this is the best way. So this gets kept alone. Okay, so now I'm going to distribute, and this is what I was struggling with before, making sure that 10 times 6/5 is a whole number, which it is, so that's 12x. And now I just have to combine like terms. I'm going to add 8x, and then subtract 3. So negative 3 over 11 is greater than or equal to x. Okay, this next lesson is a very far departure from what I was just doing. This has to deal with solving an equation, but with factored polynomials already factored. So you guys should be experts at factoring by now. So in this first example, all we have to do is set each part equal to 0. So think of this as a part, this as a part, and this as a part. So I'm going to take x equals 0, so that's done. 2x plus 1 equals 0, and then x minus 3 equals 0. Now I'm going to solve each one, and then I'll get x equals negative half, and then this one will be x equals 3. So we got 3 answers, and that's all you have to do for this. So let's take a look at the next one. This one, again, looks intimidating, but all it is just setting up the problem, just a little bit more work. So I'm setting each part equal to 0. This, by the way, is called the zero property rule. And then this is x equals 1, x equals negative 4, x equals negative 5 halves, and x equals negative 7 thirds. Okay, try these examples on your own. So the first one, negative 5 equals 0. I'm not even going to write that because clearly negative 5 and 0 don't equal each other, so you can actually just cross that out. That only happens if it's just a number. If it's like letter B, then I have to actually write that. So I'm going to set up my equations. Sorry, I'm having pen issues. and then I'm going to solve each one. Okay, and then the last one, notice this one has 2x plus 1 squared. If I were to expand that, I would end up with the same x answer, so we don't have to write it twice. So I'm just going to write it once. Again, if I wrote 2x plus 1 equals 0 again, you'll just get the same answer, so save yourself the time. So this is x equals 0, x equals -3, and then x equals -1/2. Okay, so the previous lesson was using the zero property rule. This lesson is the exact same thing, but there's an extra step involved. You have to factor. So, like I said, you guys should be experts at factoring in my previous videos. So if you struggle with factoring, and some of you will, because it's a difficult topic, you should definitely go back and watch the list of videos that I have for you. So this is a difference of perfect squares. So that's going to be 2x plus 3, 2x minus 3 equals 0. Now I'm going to use the zero property rule and solve for x. And those are my two answers. Just to fulfill some curiosity for some of you, because the equation had a squared in it, that means you're going to get two answers. So if you look at the next question, there's a cubed in it, that means I'm going to get three answers. So the next one, I have to factor out the GCF. And then I'm left with the difference of perfect square, which I call DOPS. And then set up my equations. And then you'll see I'm going to get three answers. And that's supposed to happen. So this is, sorry, I'm running out of room here. So that guy is x equal, I'm just gonna put over here on the left. So that's 1, 2, and then this last one. And then this one's gonna be x equals the third. So let me circle them so you can see the answers. Okay, I'm gonna factor the GCF. There's a DOPS inside. Set each one equal to 0 and solve. So this, sorry, minus 2. So x is -2, plus 2 plus 2. X is equal to 2. Please show all your work. Don't skip. I think you guys know by now that for your homeworks, I've been taking off points for no work. Some people have been saying, well, I do it in my head. I need to see the work in your head. So please show all your work. Okay, so the next one, I'm gonna, sorry, 2x plus 3. I have to factor the DOPS in the middle. And this next part, there's nothing to factor. This does not factor, so don't even try it. So this is 2x plus 3 equals 0, x plus 5 equals 0, x minus 5 equals 0, x to the 4th plus 1 equals 0. Okay. Okay, so here I end up with x to the 4th equals -1. So here what we have to do is take the 4th root. I'm not sure that we talked about cube roots or 4th roots, and I honestly think that this is just a typo in your textbook and that it should have said x to the 4th minus 1, because nothing to the 4th power is going to get you a -1 or at least in this course. If you move on in math, you'll find out that it's actually an answer or something else. So here there's no solution, so I'm going to write NS. So this one we only have 3 answers. Again, I think there was a typo in your textbook, and it should have been x to the 4th minus 1, which then it would have been a DOPS that you had to factor. Okay, so here is some factoring. Like, we were factoring before, but now we're factoring the hard stuff. So this is what I call harder trinomial. Here's my side work. And I'm going to use this. So I have 6x squared plus 2x minus 9x minus 3 equals 0. Factor by grouping. And then we get 3x plus 1, 2x minus, oops. And this is a skill. Just like adding and subtracting numbers, you should be able to factor now with ease. And I am very aware that not everyone's going to be able to do that. You must rewatch my video and practice factoring. I'm sorry, there's nothing else that I can suggest. It is what it is. So those are my 2 answers. Okay, I have conveniently left myself no space for this problem, so let me just block this off, and I'll use red. So 6, I have 1, 6, 2, 3. This is going to be negative, 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 positive, and then it's going to be this one and not this one, because of this last term is positive 3. Okay, so this is going to be 2. Let me do my work up here. 2x squared, sorry, I forgot my x's. 2x squared minus 2x minus 3x plus 3 equals 0. Factor by grouping. X minus 1. X minus 1. This will be x minus 1. 2x minus 3 equals 0. Set each one equal to 0. Okay, add 1, add 1. So this will be x equals 1. Add 3, add 3. Divide both sides by 2. X equals 3 over 2. Okay, I'm sorry that my work kind of went on the problem. Okay, try these examples. Okay, both of these will work. It's not this one, it's going to be this one because this was positive. So then this is going to be 8x squared minus 4x minus 6x plus 3 equals 0. Factor by grouping. While I'm doing this, I'm going to just set each one equal to 0 and solve. If you notice, this is our second example where there's 2 possibilities. And explain this in my factoring videos, you have to make sure you write all the factor pairs out because of exactly this problem. Well, there are 2 that could work potentially. And let's say you went with the 2 and the 12. What's going to happen is when you get to this step right here, it's going to be wrong and you won't be able to continue. All right, let me use a different color here. All right, so this one, I'm going to use my LCM trick because I have fractions. And I'll get x squared minus x equals 2. And notice every single problem before was set equal to 0, so I'm going to subtract 2 on both sides. And I got x squared minus x minus 2 equals 0. Finally, a basic trinomial. So let me set up my x's here. So the 2 and the 1. This will be negative and positive. Yep, negative 2 plus 1 is negative 1. And then I'm going to set each equal to 0. Okay. So if you struggle with factoring, this lesson will be a struggle as well, so make sure you review my factoring videos.